I want to talk now about combined cycle power plants. About, 15 years ago, CPS Energy built its first combined cycle power plant. I think H.B. Zachary was the construction entity, and a number of UTSA grads, civil and mechanical, work for Zachary in town, as well as out of town, all over. They have offices all over. But CPS got into combined cycle power plants. And this is a picture of a combined cycle power plant. When you look at something like this, it can be very overwhelming. So let me break it down for you. What you have is you have natural gas cycle like this. Maybe I should start it here. The air comes in, goes through a compressor, you add natural gas, you go through the burners, and you go through a gas turbine or multiple gas turbines. And then you have a heat exchanger to where you're transferring heat out of that warm exhaust gas into water. You're boiling water. And now you put it into a vapor power cycle. So you have a gas power Brayton cycle and a vapor power Rankine cycle. Now, this is very simple the way I've shown it. Actual plant have a little more enhancements, but that's the basic idea. So you still have some warm exhaust gases right here. Here's a schematic of a power plant. Let me just outline it. I can tell that it has a gas turbine right here and that's an electric generator right here, an electric generator right here, an electric generator right there. It has a gas turbine and a gas turbine and a steam turbine. And the air comes into this system. They go through some filters. They turn and come down. And they go around, as we've shown, and into the gas turbine and flow that way through the compressor, combustor, turbine stages. And then the exhaust goes out this way for the gas turbine. Now, these monstrosities, and they are large, are the heat recovery steam generators. Pretty obvious. Must have been an engineer to name that one. It's not much of a acronym, right? HRSG or something, HRSG, heat recovery steam generator. And they have multiple sections like this, and they're to recover the heat as well as clean up the emissions. They're pretty complex. And then here is the emissions finally going out after it passes through, collects and goes out. Okay, so in here, if you're going to have steam generation, you're going to have some pipes that are going to be connected to back over here for that steam generator. And then once you have the loop there, you have to condense the steam, and you'll then have to reject some of that energy. And what do we have way back here? A set of cooling towers that are going to reject heat eventually to the atmosphere. So a series of cooling towers. So then the condensed steam would go back and more steam generation. All right. So after the electric generator, you have big conduits for all the electric power to come out. They go across, and over here probably is we call that electrical, when they have a little grid, little paved parking lot with little transformers. Substation, yeah, to put it into the network, to boost the voltage. And so that's coming out, and this one's coming out. These can be run with this turned off. These can be run with one of the gas turbines turned off to match the demand in the city or in the network, in the grid. So I like these plants. They're just like engineering marvels. There's a lot going on. You can see a lot of videos. Alstom is a designer of power plants. I think one of the UTSA grads actually works for them, not near San Antonio, somewhere else in the U.S. It's a very good career. And they are reaching for the combined cycle power plant. What is this? 60% plus efficiency. That's incredible. That's a huge engineering feat. Where if you just have a simple cycle power plant like natural gas only, maybe 40-ish%. So this is tremendous. Some of them in Europe are the ones that are pushing the envelope, some of the Siemens. And then here is also the GE, and they have 60, the flex efficiency 60, so they're pushing the 60% combined cycle power plant. Watch some of those. All right, you probably purchase electricity from CPS Energy. We do in this building. That's CPS Energy supplies UTSA all of the electricity. And this is, if I didn't emphasize it already, very unique. It's the largest in the nation local municipally owned utility. Austin has one, Houston does not, Dallas does not, El Paso does not. It's very unique, okay? And so basically we own this utility, CPS Energy. And there's a plant in Seguin. It's the Rio Nogales plant, if I pronounced that correctly. It's a natural gas fired power plant, but here's a picture of it, grabbed it out of a newspaper. Can you tell what these are? 3 of them. Air intakes for gas turbine. You have 3 heat recovery steam generators. You have 1 building for the steam turbine as well as the electric generator connected to that steam turbine. And in the back, what do you have? A bunch of cooling towers to reject the heat to the atmosphere and to make your cycle. And right over here is your big parking lot for the electrical, putting into the grid. And if you know, here's San Antonio, here's Seguin. What is this road going toward Houston? I-10. So if you've ever driven I-10, and as soon as you cross this little blue line, that's a little river. Anybody know what river that is right there? Guadalupe? Yeah, Guadalupe River. Right here is 46. 46 goes New Braunfels, cuts around like that. This is 46 coming across. So you cross the river, you come up, you cross 46. There's a little kink in the road, and you can look at it right there. Easy to see, just on I-10. No, you're a passenger, you can look at it. You're a driver, you can't look at it, right? But there it is. And so CPS owns that power plant. They purchased it not that long ago. It was privately owned, and then CPS wants to get rid of the coal plants, and they have to buy other plants or build them.
Have you ever worked in it?
No. Love to, though. It's a good, very good job.
Is this combined cycle somewhat similar to the organic Rankine cycle?
The organic Rankine cycle would typically use low heat sources, low temperature heat sources, like geothermal or solar, a low temperature solar. They can have high temperature solar as well. But organic Rankine is just getting away from water and using something that has a different boiling and condensing points. Typically something with a hydrocarbon, the carbon. Oh, I forgot to cover these up. Oh well. In 2016 or 2017 now, right? Blank is the most common type of new electric generating power plant being built in the United States. Are we now diving big into coal, building a lot of coal plants? Are we diving big into natural gas and building a lot of natural gas power plants? Are we diving big into nuclear and building a lot of new nuclear power plants? Are we building a lot of biomass power plants? Are we building a lot of hydroelectric? In the United States, not the world. This is in the United States, your country. What are we building? Natural gas. Everybody's going natural gas. Yeah. Okay. Here's the next question. This one I'll put on the final exam and people won't get it right. Combined cycle power plant. Combined cycle power plant is one that uses coal as the primary fuel source, natural gas as the primary fuel source, both coal and natural gas, both wind and natural gas, or both coal and wind energy. And believe me, I'll get all 5 of those answers on the final exam. I've given this question on the final exam. Basically, natural gas. It's natural gas. But when you talk about a combined cycle power plant, people think, oh, it's got to be 2 things. Oh, it's got to be coal and something. No, it's really just 2 cycles. The vapor power cycle and the gas power cycle. So there you go. So we're done with that.